Welcome to Hot Chips 30. Tutorial 1. Blockchains and Distributed Ledgers.
So good morning. Welcome to Hot Chips, to the first tutorial. My name is Geoffrey Burr from IBM Research Almaden, and I'll serve as the session chair for this first tutorial until about lunch. I do have one message from the organizers that I've been asked to deliver before I introduce our first speaker, which is to remind you to put the parking pass, and not just any parking pass, but the right parking pass for today on your dashboard of your car. And make sure it's there. And with that, I would like to introduce the first speaker of our tutorial. He'll speak to about 11:15. And so it's an honor to have here Dr. C. Mohan from IBM. Dr. Mohan has been an IBM researcher for 35 years in the database area, impacting numerous IBM and non-IBM products, the research academic communities, and standards, especially with his invention of the Aries family of database locking and recovery algorithms, and the presumed abort commit protocol. An IBM fellow since 1997 and ACM IEEE fellow since 2002, he also served as the IBM India chief scientist for 3 years. In addition to receiving the ACM Sigmod Innovations Award, the VLDB 10-year Best Paper Award, and numerous IBM awards, Mohan was elected to the US and Indian National Academies of Engineering in 2009 and was named an IBM Master Inventor in 1997. A distinguished alumnus of IIT Madras, Mohan received his PhD from the University of Texas at Austin. I will skip the year. And he is an inventor of 50 patents and is currently focused on blockchain, big data, and HTAP technologies. With that, I ask you to welcome Dr. Mohan.
Thank you, Jeff. Good morning, everybody. Thanks for coming on a Sunday morning to listen to this material. It's nice to be in this auditorium. I've been only on the other side in the past. This is the first time I'm on the stage in this very famous Flint Center. So this presentation I've been giving since April of last year. That was my first presentation on blockchain, and that was in actually 2 universities in Hong Kong. Since then, I've given it in 9 countries, and I'm about to go to Brazil on Friday, and so the International Conference on Very Large Databases is taking place there in Rio, and so that'll be the 10th country. So it's been incredible in terms of the amount of interest that has been shown across the globe, and that's the point in saying, 10 countries and so on, in this topic, much more so than what I worked on for 35 plus years, which is hardcore database topics. Since my research lab in San Jose is where relational databases came into existence. Ted Card, the guy who got the Turing Award for that work, used to be my colleague. And also the language SQL came from my research lab. So all the other things that happened were as a consequence of this kind of activity that happened in my research lab. So I've been a hardcore database guy working on recovery, locking, and such topics, really low-level, nitty-gritty, details-oriented stuff. So all my professional life, I've been at IBM, but I also have this affiliation with Tsinghua University as a distinguished visiting professor for the last couple of years. Plus, I was the IBM India chief scientist based in Bangalore for almost 3 years, from middle of 2006. So what you will find is that in this presentation, all this long history I've had working on industrial strength database technologies is something that will be of great relevance because there's been too much hoopla in this space that's based more on people not really systems-oriented people doing things and making all sorts of tall claims about how open blockchains are going to solve the world hunger problem and all sorts of, incredible claims that have been made with decentralization and no trust, blah, blah, blah. All sorts of goodies can come. But in fact, they wasted a lot of energy and such with these open blockchains, with this notion of proof of work and such. Of course, as most of you probably are chips and such people, maybe, you know, at least some of you don't care for all the energy wastage that's happening in this particular space with special purpose chips even being developed, ASICs and so on, in order to do this proof of work computation more efficiently and things like that. But I have fundamental problems with that whole approach, in fact. That's the right thing to be doing. So my major focus will be on what I call private blockchains, which have the potential to really be of practical consequence rather than fringe people or, you know, people who are out to try to make money really fast through ICOs and all these terms that you will be hearing, which are different from IPOs, initial coin offerings, instead of initial public offerings. I'm not so fond of that kind of activity. I'm more into making a real-world difference with things that have the potential to become practically very relevant and so on. So in case you are interested in looking at the slides, I've already tweeted, so my handle you see there, SEEMOHAN, as well as in other social media forums. I put the link, just did it this morning. So it should be easy for you to go look at the bit.ly link. The other point I want to make is that the bit.ly link that you see at the bottom of the slide, if you go there, you'll find lots of very useful information, links to PowerPoints and presentations and papers, both very technical papers as well as more fluffy white paper kind of documents, and also, you know, good Twitter handles to follow and things like that. So if you like the presentation and you want to learn more, or you want to tell your friends who are not here about this work, please point them to that, share and tweet and all that, because I'm really out to evangelize these private blockchains, which, as I said, are the ones I believe are going to really make a difference as opposed to overnight millionaires and such things that are the norm with a lot of cheating and all that that's going on in the public blockchain space. There are good things also happening, but more of it is hype than good, really. So, okay, let's see. So this slide, unfortunately, okay, sorry, I skipped this slide. So this gives you the overview of the presentation. Basically, it's targeted at anyone that might or might not have had any exposure at all to blockchains. And it's even targeted at non-technical people, which doesn't apply to, I'm sure, any of you, because I'm sure you're all technical people. So I'll introduce the topic and give you some pointers to other places where you can find even more detailed information and so on. So I'll be going into different levels of abstraction. Sometimes I'll be at the 10,000-foot level, sometimes I'll get into the weeds and so on. So, of course, as you probably know, I'm here for the first time. So Jeff is going to be the man who's going to police the questioning and all that. And if you want, you could ask questions in the middle. The only problem is, given the size of the auditorium and the fact that some of you chose to stay way behind rather than being up front when there are so many seats here. There are two microphones, one you see there and another one over there. You have to come there to ask the question. I assume it's being recorded also, so for that reason too, they want to make sure that you don't just shout it out in case that doesn't get picked up by the microphone for the recording purposes. So, but definitely there'll be time at the end, and I'll also hang around during the break as well as the lunch. So I'm going to be listening to the next presentation also on Ripple. So I'm going to also skip, as a result, some of the material that I normally show about Ripple, which the next speaker from the Ripple organization itself will be talking about. So I'll talk about some of the applications, use case scenarios that go far beyond just the fintech space, which is where some people keep thinking that because of the concept of cryptocurrency and all that, that's where the major focus is. In fact, there are many non-financial industry use cases that have become really heavily focused on, and there are even production deployments and things like that. I'll also say a few words about the market scene and some standards activities that are in progress. It has to be understood that in this space right now there are no standards. It's somewhat chaotic, but not as chaotic as, let's say, the NoSQL space, for those of you who are more software-oriented. There isn't like a SQL language standard in this space. And so, as a result, you need to be very careful if you're choosing a system, which system you use, because its APIs are going to be different from some other systems' APIs that are out there. More importantly, there isn't even a conceptual model for these blockchains that's common across these different systems whose APIs might be different. If you think of the relational arena, when the original implementation was going on in my lab, SQL language came about as a result, whereas at Berkeley, Mike Stonebreaker and others were with the same relational model developing a system, but they developed their own language called Quell. But at least the underlying conceptual model was the same, whereas here even that is not the case, as you will see. In terms of architectural choices, I'll discuss some of the choices that have been made. When I say architecture here, not necessarily computer architecture, but even the software architecture. Elements of that architecture, different choices have been made by the different systems. I'll also give you some of the details of some systems that are out there, and then areas that require a lot more work and so on. So you have to think of this whole space, at least the private blockchain space, to be in the same state as relational database systems were 40 years ago. A lot of stuff had to happen before they became really, useful and easy to use, and all sorts of tooling and all that got developed. So in terms of, for those people who might be looking to, start companies or start research projects, whether you're a student or a faculty member, in any kind of research organization, either commercial labs like mine or in academia, there's a lot of scope, and we'll discuss some of that at the very end. So this slide, I'm sorry you can't easily see it unless you maybe go, if you have your laptop, and look at the presentation itself, is trying to summarize, exactly how all this came about and so on. So the initial work that triggered all this current mania, if you like, in the blockchain space came from this paper that was written with a pen name, but a Japanese-sounding name. Nobody knows who the real person is or real persons are that were behind the paper on Bitcoin. So the idea behind that paper was that, fiat currencies are bad, so we are going to cook up this new kind of currency, which is like magic, you just waste a lot of energy and suddenly you create some coins called Bitcoin. And I'll get into some of the details a bit later. But the underlying data structure for this Bitcoin is the blockchain. So we are more interested in that underlying data structure than the notion of Bitcoin itself. And all the subsequent developments that have taken place have resulted in many more such cryptocurrencies coming into existence. Ether and all sorts of ICOs that I mentioned. Many companies are cooking up their own things, tokens or coins, they call them, virtual coins. There are various terms that are floating around for these things. But in general, there is a certain passionate set of people out there who think governments are bad, and since fiat currencies are issued by governments, these libertarian kind of oriented people think by just coming up with a single virtual currency, cryptocurrency, somehow all the world's ills will be taken care of. This is all wishful thinking. So those of you who have been old enough to have been around when people thought linguistic problems of the world could be solved by coming up with a single language, that didn't happen. There is no chance in hell that any of this is going to be true, that one currency, whether it's crypto or non-crypto, is going to be adopted by the whole world. So having seen the hype that was made at one point with a natural language being adopted widely and that not coming to fruition, and already there is sign now that there are so many of these cryptocurrencies themselves. It's not like Bitcoin is the only thing around the globe that's there, but it's become also a big problem in terms of performance and so on. So if you look at the numbers there, 7 transactions per second and 10 minutes for the outcome of a transaction to be known, whether it succeeded or not, where a transaction is essentially sending a certain number of Bitcoins from one person to another person. I mean, there were like 35 years ago, we used to talk about 1,000 transactions per second in the traditional database transaction processing arena as some big deal thing. And of course, now, now we talk about millions of transactions per second and things like that, especially in the IoT context and streaming and such. So for such people, this is like, are you kidding that this is anything that is going to be of any practical relevance and so on? But there are people who are, especially a lot of 20-somethings, who think somehow this technology is going to really get rid of all sorts of ills of society. And so, of course, as it happens with this kind of thing, as these new currencies came, now you have to worry about the conversion factors between them. People who complained about the fact that, oh, China is manipulating its currency or this or that, artificially keeping its value low and such, thought somehow this Bitcoin will solve all that problem. But now that you have many more such currencies, you are back to the problem of who gets to decide and all the manipulation that goes on with respect to the conversions between these different currencies themselves, or between these different currencies and fiat currencies. So, but in any case, the world is now very excited about this, both the technical world as well as the common man kind of world. So popular press has published a lot of articles, and there are various groups across the globe that are working on various aspects of blockchain technology, from, let's say, the topic of security to consensus to database and benchmarking and on, verification and so on. The notion of smart contract got introduced as an extension of what was there in the original Bitcoin paper, where the only resource that was being managed using this blockchain data structure was this entity called Bitcoin, or your wallet, which contains Bitcoins, right? And then being able to transact by sending these Bitcoins around, to then saying, hey, we would like to use this blockchain technology to manage any kind of resource, be it a purely digital resource like music recording or a video recording, or digital representations of physical assets like diamonds and packages and spare parts and componentry, all sorts of things that you and I as ordinary citizens will be dealing with in our day-to-day lives. And so it's that transformation that's the more exciting thing. And so now we'll get into, in due course of time, the details of exactly what the big deal is with using this blockchain technology versus using traditional databases and so on to do the same sort of thing. But you have to keep in mind that all of this is very relevant only when you are dealing with a business process or a workflow that involves many organizations. If it's just something that's internal to an organization, the chances are pretty slim that you would need to use something like blockchain. But in terms of the actual real-world adoption of this technology, while there are lots of prototyping activities and POCs being done, there are actually, since early last year, production deployments all over the place. In particular, the first one had to do with an offshore fund management entity in the Guernsey Island of the British coast, where private equity funds are being managed using a particular piece of software which was developed initially by IBM, and then it open sourced it and became part of a consortium, and that's the Hyperledger Fabric 0.6 release. Okay? 0.5 was the first release, 0.6, and then the even more production strength thing that was released middle of last year, about a year ago, is the 1.0 release. And but these guys went production with even the earlier than 1.0 release of that system, which is now developed in a consortium fashion under the Linux Foundation, since this Hyperledger Consortium is part of the Linux Foundation. But there are many other projects under that the Foundation's umbrella, and we'll talk about some of them, including, for example, Sawtooth, which Intel initiated, and that's had its 1.0 release come out more recently. This 1.0 release is considered a big deal. That's a statement by the consortium which says that this is ready for prime time kind of statement. So meanwhile, IBM announced blockchain as a service offering. You'll see lots of other vendors also making announcements, if not actually making their BaaS offerings available. In particular, for example, Oracle has announced last October that similar to the IBM offering, based on the blockchain Hyperledger Fabric 1.0 release, they will have a blockchain cloud service. But it's not yet available. It's supposed to have become available in the next few weeks and so on. That's what they've been saying for the last few months. But IBM's offering has been out there even based on the 0.6 release, and it runs on the mainframe, believe it or not, leveraging some really fancy features of the mainframe, which are even far superior compared to the SGX feature in Intel platform, which has to do with secure execution enclave. And we'll talk about that also a bit later. But more recently, that IBM offering is now called the IBM Blockchain Platform since the 1.0 release of the Fabric. And that has been deployed also in production mode by various people that have implemented solutions on it. The distinction is that you can download the open source software and run your own thing. But if you want a managed offering, that's what this blockchain as a service is, which means you have to pay some money to IBM. And there are others, Huawei and so on, that have also come up with such things. And there's more of it that's going on. And also the Hyperledger Consortium started a project fairly recently, which is attempting to come up with benchmarks. It's called the Calipo project. And the original Bitcoin work got extended with the notion of smart contract that I was mentioning to manage different kinds of assets than just a cryptocurrency. And that resulted in a system called Ethereum being developed. But that also had the same sort of problems as the Bitcoin system, namely the way in which things worked over there. For instance, how a set of new transactions get to be put up for being executed, and who succeeds in getting a new block of transactions getting executed is determined by this concept of proof of work, which is essentially a way of making the different people who are attempting to get the opportunity to add a new block of transaction to the existing blockchain to solve a math problem. This was an attempt to, by the original designer, in the presence of any kind of people out there whose identity you don't even know, to make them go through some pain in order to make sure that they are not out to screw up the system. See, this is the so-called Byzantine behavior that they are worried about, which is not just the traditional kinds of failures where a node fails or a disk drive fails or a communication link fails, but you also have people who are intentionally trying to screw up things where they might say one thing to one person or one system and just the opposite thing to another person or system, when in fact they are supposedly saying something about a particular fact or whatever, and they are giving conflicting information. It might be reminiscent of something else that's going on in this day and age in our country, but let's not get to those sorts of discussions. But all this, lying and everything. So in order to prevent people from hijacking the whole blockchain way of doing business by people who exhibit Byzantine behavior, they came up with this idea of making them waste in my words, a lot of energy so that, it'll appear like they are being serious, and hence there's less likelihood of them being these bad actors, okay? But that's what results in this incredibly lousy performance of 7 transactions per second and things like that. So this notion of asking people to solve a problem, which is this proof of work idea, is part of the Ethereum way of doing business also, which as a result also makes the performance there not at all that good. Of course, there are attempts to address these sorts of issues by coming up with these things are called consensus protocols, proof of work, proof of stake, and various other ones that are being proposed as we speak. There's even a Turing Award winner at MIT who has come up with his own, Silvio Micali, and I'll be discussing these things with him next month at the Heidelberg Laureate Forum in Germany. Along those lines, the Ethereum system also is an open blockchain because anyone, anywhere can willy-nilly come and go without having to reveal his or her identity. And that also is a bigger problem because everybody can see what's being transacted on such an open blockchain. It's an open kimono kind of way of doing business, which real enterprises and other kinds of organizations that worry about privacy and such, or competitiveness between organizations, are not going to be happy with. And that's another reason not to let anyone anywhere come into the party without any checking being done as to who they are and so on. So that's the way the private blockchain deals with this issue, so that only people who have a reason to be there, because they are participants in a business process, will be allowed to be members of a private blockchain network. And the current participants get to decide who the new participants can be. And it's not just because somebody has some, compute resources available and they have nothing else to do, that they just come and join the party, which is the way things work. And as you probably all have heard of these server farms up the wazoo that are in China and certain parts of Canada and other parts of the world, whose sole job is to, with special purpose chips and so on, try to do this mining, because the people who do the mining, proof of work, and who win the competition, because multiple people are trying to do the same thing, get a few biscuits thrown at them. It's like a dog does a trick and then you throw a few biscuits to reward it kind of thing. So in this scenario, the bitcoins get thrown at them. So, and that's how bitcoins get created, as opposed to being just moved around, because you have to worry about where do they originate. And the paper also artificially set a limit on ultimately how many bitcoins will exist in the world. Again, who are these people who are coming up with such things? They are not economists. And so, yeah, you can say, in fiat currency, governments are willy-nilly printing notes and so on, but there are enough checks and balances in the governmental way of doing things that fiat currencies, even though you can give examples of Argentina and some countries where things have gone crazy and such, still across the globe, the Federal Reserve, the Central Bank, the Reserve Bank of India, and such organizations out there that do police this kind of activity, and they try to relate it to real-world services and goods that get produced, not this, I'm just a computer geek and I'm going to cook up some algorithm and think that I'm creating money with no real relationship to real-world economic indicators of productivity and so on. So this is the other reason why this is a problem. In any case, even the Ethereum people, in due course of time, have realized that at least in certain scenarios, they need to have this private blockchain orientation, and hence the emergence of what's called the Enterprise Ethereum Alliance, which is trying to take the Ethereum technology and bring it into the private blockchain domain. And in terms of the market, it turns out this global blockchain technology market by Grandview Research has estimated it to be about $7.74 billion by 2024. These sorts of numbers, you just want to get an idea of the order of magnitude, not the exact numbers and so on. Somehow these guys cook up these things, Gartner, IDC, and so on, as to what the future market will be and things like that. So my focus will be on the private permission blockchain. In terms of job markets, and some of you might be interested, there are lots of jobs out there for people who are willing to work on either the private blockchain or the public blockchain. So these are some of the headlines from some articles. Cryptocurrencies and blockchain are becoming a hot trend in the job market. Blockchain moves into top spot for hottest job skills, blockchain jobs and salaries, 2018 report, and so on. So if you go to the presentation, you'll see more of this kind of information. In terms of also jobs and particular geographies, as you can see here, the New York and San Francisco cities have lots of job opportunities. Silicon Valley doesn't show up as a separate category, but individual cities are there. That's why you'll see Palo Alto and Menlo Park and Sunnyvale and so on also there. This is just to get you an idea of what the different kinds of areas are in which there are job openings. So the key there says unemployment rate, number of crypto funds, number of blockchain startups, number of top blockchain companies, number of blockchain job postings, okay? If you are from Europe, how many of you are non-US based people? Okay, pretty small number, okay. If you are from Europe, there are a whole bunch of projects that have been initiated by the European Union, and this slide, when you go click on it, it will point you to various projects and so on. So in terms of organizations, it's small companies, big companies, it's NGOs, it's venture firms, governmental entities, all sorts of parties, little countries and big countries that are all working on these things. I've already discussed what the Bitcoin's original goal was, to create this notion of Bitcoin, a cryptocurrency, and then let people, for presumably goods and services that are being exchanged, real-world goods and services, pay each other using Bitcoin. So the way it works in terms of identity, you don't really reveal your identity. There is an address that's unique that essentially represents you, a particular person, and there's a leveraging of public key and private key. So you expose to other people your public key, but you hide from everybody else your private key, and other people will send you money using your public key and your address. If you lose your wallet, which is where you are keeping your money that is in your account, you are completely gone. Meaning, if you forget your private key, there's no recourse to any authority or anybody. So in that sense also, this is all very crazy, It's not like having money in a bank, FDIC insured, this, that, and such. Of course, as you can imagine, because it has this anonymity, there are any number of people who are out there to do all sorts of sleazy things who have leveraged it, from drugs to prostitution to black money and so on. So countries like India and various other countries, including the US, there are many people whose eyes light up because now they think they can very easily convert their fiat currency into Bitcoin, and then they can move it around the globe and do all sorts of dealings that are under the radar of governmental authorities. For that reason also, many governments are not happy with it, and actually many governments have banned these cryptocurrencies in general, not just Bitcoin. And so currently there's a lot of debate also about, are these things like securities or not, and so on. This whole ICO notion was introduced by some people who wanted to raise money in the market without going through all the regulatory requirements of IPOs. Should be reminiscent of what happened in 2007 and 2008 with these mortgage-backed securities and such concoctions, which were primarily targeted at circumventing the SEC kind of regulations and federal policing and such. And we know what the disastrous consequences were of that thing. So in that sense also, currently there's a lot of concern about what's going to happen with these things. In any case, this just shows a particular scenario where Bob and Alice are exchanging some money, okay? In terms of how this thing works, if you're a geeky kind who wants to get into the weeds, there's this concept of, as I said, money being created that's done through what's called coin-based transactions. The money gets created because they want to reward somebody who took the trouble to solve that math problem, do the proof of work, and got the opportunity as a result to add a new block of transactions to the existing blockchain. So the blockchain starts with nothing in it, and from then on, money gets created and also gets exchanged. And so I don't know how it gets initialized, because what is there to transact to begin with? Nobody has any money. So I'm not sure what the initial transactions are doing in this kind of a scenario, but let's ignore that for the time being. But in general, the transactions are A sends money to B. Now, that transaction is declared to have actually happened successfully only after these miners verify that, in fact, A had enough money to actually send this, whatever, 5 Bitcoins to B. And that the same 5 Bitcoins are not being sent to multiple people. That's called the double spend problem. This is like running to an ATM and grabbing money and then going to another ATM before the central server gets updated with the reduction from the first withdrawal. You go take money from another ATM. This sort of silly things used to happen in the good old days. But anyway, here, so the idea is that you start a transaction, but it'll be a while, like 10 minutes, before you find out whether that particular transaction succeeded or not. And that's also kind of mind-bogglingly dumb. The way the whole thing works, they don't even keep the current balance in order to check this, is this a legit transaction? They actually go back to the beginning of that blockchain, look through all the transactions that this person has been involved, the one that's sending the money, and then they compute. For every transaction that this guy does, they compute what his current balance is. Given that current balance, is this transaction that this guy attempting to do acceptable, or is it legal or not? Legal in the sense of it's legit in this context, that he does have the money that he is trying to send. So from a computer science viewpoint also, this is all pretty inefficient way of doing business. And if the blockchain has existed for 10 years. Imagine rummaging through all those 10 years worth of transactions and figuring out whether the current transaction makes sense or not. If you want to know more about some of the data structural aspects of what this blockchain thing looks like, for those of you who are into logging and recovery in systems, this is nothing but a log of the different transactions that have taken place over time. But unlike a traditional recovery log where we don't worry about Byzantine behavior and such, here the data structure has enough features built into it to make sure that if somebody tampers with a page of this blockchain or multiple pages of the blockchain, the fact that it's a tampered version than the original version can be detected. You'll hear a lot of these phrases like immutability of the blockchain. It's not all that novel. I mean, traditional database recovery logs, we never do in-place update. We only append new transactions to the log. This is no different from, in a banking context, ledgers, let's say you deposited a $1,000 check, but erroneously it got recorded as a $100 check. And then you later find out when you get your monthly statement out, oh, what the heck? I mean, this is wrong, clearly. So you go argue with the bank people. When they fix that error, they don't go change the original entry. They put a new entry saying, hey, this is a correction to that old entry. So there is a complete recording of what happened when, by whom, and things like that, for auditing purposes and so on. So that's precisely how this blockchain thing also works. When new transactions get appended, no changes are made to pre-existing things that are already in the blockchain. So in order to detect any tampering where somebody is trying to misbehave, what they do is they compute the hash of each block, and in the next block, in addition to a pointer potentially being there which makes block n point to n-1, block n also contains what the hash of n-1 is. Okay? And the idea being that if anybody modified even 1 bit in n-1 after it was originally created the legitimate way, this hash will not anymore match the hash you compute with the new version of that block. Okay, this is all, folklore these days about relying on hashing as a way of detecting any tampering. Of course, this brings into the picture all the things about SHA-128 and 256 and how much any of this is going to be withstood by quantum computing and that kind of technology. And we already know that 128 can be reversed. That is, you can cook up a way of modifying the page in such fashion that the hash is still the same and things like that, right? So this is all subject to, these other sorts of technological advances not screwing up this ability to detect such tampering and so on. But in general, this concept is called the Merkle tree, which allows you to essentially, by computing hash on one thing and that itself having a hash of some earlier thing and such, any tampering along the way can be detected is the idea. And I'll let you go into the details. So there's a paper that was published in the ACM Q magazine by Arvind Narayanan and his colleague Jeremy Clark at Princeton that gives you, from a historical perspective, even though the Bitcoin idea was something that came out in a paper around 90, I think. Where is it? I'm having a senior moment. No, sorry. Here it says Bitcoin 2005, but it's not. The date is somewhere here. First line, yeah, thank you, 2008. That is Satoshi Nakamoto, okay? So it turns out there are ideas from the early 80s which all got combined by this fictitious person or group of people that resulted in the idea of Bitcoin being proposed. But this is getting more into the nitty-gritty of the data structure itself, this Merkle tree and other associated exploitation of hashing and things like that. So you can go read that. In terms of money, as I mentioned before, many startups right in our backyard have been raising money through this ICO process, and they, of course, will tell you that this is a great thing because this is like crowdsourcing. We don't have to go please the guys on whatever that road is in Menlo Park. The VC firms that try to take away a big chunk of your equity, ownership of your company, and so on for the money they give you for seed funding and this and that. But it turns out, while it took off a great deal last year and a little bit early this year, suddenly there's been a dip in the money being raised through ICO process because finally the authorities, at least in the US and in some other countries, woke up and said, okay, there's a lot of sleazing going on here where, ordinary citizens' money is being ripped off by these guys putting out just white papers, not going through as rigorous a process as it's required when you are doing an IPO filing in order to reveal all the what's in your ideas or whatever systems you are developing or some prototyping that you have done and things like that. And so that resulted in certain declarations. For instance, it says the CFTs, the Commodities and Futures Trading Commission, declared that crypto assets will be treated as commodities. That's like, wheat and such, right? The financial, I forget what the letter C stands for, something enforcement network. So they said they're going to think of cryptocurrency or ICOs as money. And meanwhile, the SEC said they want to treat them, except for Bitcoin and Ethereum, the rest of the cryptocurrencies out there, as securities. And so consequently, each of these organizations said, I'm going to expect you to now give me all sorts of information about what you've already made out with your ICO and things like that. So this has put a damper on the number of such ICOs and such. But turned out Companies like McKinsey have put out a few reports recently. So this is the June one, which talks about some of the myths about blockchain. Blockchain is Bitcoin. Blockchain is better than traditional databases. Blockchain is immutable or tamper-proof. Blockchain is 100% secure. Blockchain is a truth machine. Because there's lots of hype around this whole thing. People say, oh, you know, with all sorts of shady people around, we can still do things where we have more trust. This is projected as a way of guaranteeing trust across a group of parties who are doing stuff with each other, even though they don't know each other very well. And this technology will certainly bring about more method to the madness. But in fact, not all of the statements are true. There may be some truth to some of these things, and that's what the details are. And I won't dwell on that. Now, getting to the more algorithmic aspects and technical aspects of all this, turns out there are many technologies that have been developed both in the distributed systems arena and the database arena, which is this next slide, which have a bearing on what goes on here. Believe it or not, late 81, when I joined IBM Research in San Jose, soon after that is when Byzantine agreement protocols were being worked on in IBM Research, right in my own lab, where people were coming up with clock synchronization algorithms and things like that. Danny Dolev and Barbara Simons and people like that, Ray Strong. Joe Halpern even worked on distributed knowledge and things like that. So it's not at all that new, the notion of some people misbehaving or nodes in a network misbehaving intentionally. And long before all the bad things that we all now know about viruses and this and that came commonplace. And of course, people like Leslie Lamport, another Turing Award winner, came up with this notion of, Lamport clocks and how to synchronize in an asynchronous way different systems activities and ordering events and things like that. A lot of those things are extremely relevant in this context. Of course, later came things like RPCs and transactional RPCs and also message passing systems with transactional messaging and queuing, as well as PubSub and, of course, event-based systems with distribution events and things like that. So, of course, the more even relevant stuff, even more relevant stuff is workflow management systems and business process management systems, where a particular activity involves a whole bunch of organizations, geographically distributed, even potentially across the globe and things like that. Many of those systems had certain characteristics that made them not so efficient or fault tolerant or not keeping track of all the things that were going on in a way where it made it easier for you to later on do some root cause analysis and things like that. So you can think of domains where some of that will be relevant. If some food poisoning happens and you want to figure out where what came from, when, and how it was transported, and what the temperature in the truck was when the transportation took place, could it be that the air conditioner in the truck had failed and that's why this food got spoiled and nobody did anything about it until some people consumed it and then they died because of this problem? Things like that, right? And then, of course, the cloud and the service-oriented architectures and so on came. A little before I joined IBM is when all this relational technologies initial work happened. I joined midway through the R-Star project, which was a distributed database project. So I myself had worked on two-phase commit protocols and their variations and such in order to more efficiently coordinate transactions across different nodes. So in an atomic way, you can do a distributed transaction that modifies resources in multiple places in spite of various failures, node failure, link failure, and disk failure. We also worked on, believe it or not, in Principles of Distributed Computing Conference back in '83, a paper that combined the Byzantine agreement protocols with this two-phase commit protocol. So in that sense, a lot of this has been worked on in bits and pieces over a long period of time. But of course, in the database arena, there was a lot of work that has happened for a long, long time on replicated data management and things like that, and also warehousing versus online transaction processing, how to do analytics on transactional data, whether you have separate systems to do them or more, as has become more common these days, the so-called HTAP systems, hybrid transactional and analytic processing. So that in a single system, you can do transactional short and sweet transactions that are your bread and butter kind of money-making activities, but also analytics on that latest data rather than having to move that transactional data from where it originates to a separate place called a warehouse, build different kinds of indexes, and then do the analytics on them. This means that the analytics are done on out-of-date data. But it turns out with the modern way of transactions being done, and also the advertising-oriented way of making money and giving you the opportunity to learn about related things and such, and try to do additional sales to you, involves having to more quickly react to more recent events. And that's the reason these HTAP kind of systems have become popular. And we ourselves in Almaden research at IBM have been working on such systems, and products have come out and things like that. And of course, there was a lot of other things that happened with the Web 2.0 revolution, which resulted in NoSQL and things like that coming about, and MapReduce by Google guys, and then Yahoo and others. And of course, in the context of the web, data privacy and such have become important, transborder data flow, and I'm sure most of you know about GDPR, which just came into force in Europe, and that's introduced lots of expectations on the part of people who acquire and manage personally identifiable information, other kinds of information that's protected by GDPR, having to be a lot more careful about what they do with the data that's entrusted to them by customers and such. And of course, transborder data flow restrictions have always been a big deal in Europe, and they have become even more severe with this GDPR. And all of this also has to do with when you have these, across the country kind of business processes, exactly how the blockchain technologies are even, implemented and leveraged, and where information is kept about what all is going on becomes relevant. So in that context also, this open blockchain where it's open kimono, everybody can see what's going on, is just not a very practical thing, okay? And then of course, with multiple data centers and the cloud, whole data centers disappearing and such are also important things. Terrorism, acts of God and things like that, what are natural disasters and such. So what are we trying to do with this whole blockchain notion in a more practical context than all this hyped up cryptocurrency and so on? Look at a scenario like what you see in this slide, where it's an import-export scenario. There are multiple players, importer, exporter, forwarding agent, the trucking company that picks up the package, takes it to whatever the means of transport that you're going to be using, whether it's airlines or ships and such. And then there are government authorities which are doing inspections, customs and such people, or FDA kind of people doing, or the Department of Agriculture checking to see that you are not transporting something live and so on. So while all of these systems, all of these entities may be using computers and or even exchanging electronic messages, this doesn't necessarily mean that it's all being done in a nice and coordinated fashion, meaning each of these entities has its own database where information is being tracked. They might be exchanging EDI or XML or JSON kind of messages, but typically they tend to be point-to-point kind of messaging. There isn't a coordinated protocol that ensures that everybody has a single source of truth, be it replicated. But right now, each is on his own in terms of the programs that they use to manage the data that they are keeping, even though the data that's being kept involves all these different parties and so on. To this day, there's a lot of paper documents also, and if things do go wrong, people, after the fact, modify these documents to try to shift the blame to somebody else, in the case of death or whatever, right? And those things are hard to detect just because there isn't a method to the madness with which these things are being managed. Whereas in the blockchain way of doing business, which is depicted on the right side, what you find is that there's a single set of programs that are collectively developed by the parties to this business process, who then, in a systematic way, of course it depends on the use case, figure out whose blessing is needed before a state transition is made to the asset that's being managed in this fashion. As I said before, the assets could be purely digital assets or digital representations of physical assets like diamonds and packages and so on, right? And each of these organizations has a copy of the database, and it's the exact same copy. And people cannot willy-nilly directly go to the database and update it. It's these programs, these so-called smart contracts, which are being developed and which embody the rules of engagement between these different parties, that actually are the ones that are going to manipulate the state database in which these assets are being tracked in a persistent way. Separate from the state database, which has the latest state for all these assets, is this other data structure, which is the blockchain, which has the historical record of from time zero when this network was formed, this particular network, what all transactions have taken place. Some assets got created, some assets got destroyed, and so on and so on. And in the case of diamond, for instance, the diamond was mined, a raw diamond, and then it got polished. You had a big diamond, then it gets split into small ones, and then you sell it in wholesale and retail, and somebody buys a single diamond, gets it mounted on a ring, and presents it to his girlfriend or whatever. This whole set of transitions that are being performed on this asset, sometimes things are being split, sometimes things might be combined. Like collect a bunch of packages and put them into a big box. Collect many boxes, put them into a container, and then it gets shipped. And then again, at the other end, it gets split up back into the original components and so on. All of this needs to be tracked. You might say, hey, what the heck, don't we have tracking number that FedEx and so on gives? Guess what? They only give you a window into what they choose to expose to you. You are not able to actually see exactly what FedEx has in its database. So whereas this technology now lets you, in a more systematic way, let all the participants decide how they're going to do all this and codify it in the smart contracts. Of course, this means if you already had the pre-existing chaotic way of doing business, in order to get to this more systematic way of doing things, you do have to rewrite your programs and so on. And this is where the point I made at the beginning about no standards being there for this blockchain technology and all that in terms of API as well as the underlying conceptual model is going to be a problem until some of this gets fixed. Unless some of the dominant players in the scene today get enough of a market presence and the wherewithal to withstand for decades of the existence of that system, in which case you don't have to worry. And we have had these de facto standards in the past anyway. But again, these pieces of work are being done today in the form of consortia. So it's not as bad as the NoSQL space where every 3 or 4 guys get together, develop a new system, and who knows how long it will last and so on, because these 3 guys might shut the garage and decide to make really money to feed themselves rather than doing this open source development and doing charity kind of work. But now, in the blockchain space, bulk of the activity is being done in the form of consortium. So now you'll see flowcharts like this being shown. This is the way you decide, given your particular use case scenario, is it appropriate for you to implement this use case scenario using blockchain technology, or should you just deal with this using traditional transaction processing databases and so on, DB2, Oracle, whatever, right? It turns out this particular one put out by the World Economic Forum has a bug in it. They make it appear like you cannot deal with physical assets using blockchain technology, and that's completely wrong. I've already talked about that before. But IBM also has a similar kind of chart that's used to go help customers, groups of customers who are trying to evaluate the applicability of blockchain technology to a particular use case scenario. The notion of smart contract I already talked about. It's the generalization of the Bitcoin to any kind of asset and so on. So you can talk about taking a natural language contract and transforming it to a more formal contract and being able to prove certain properties. Those of you who are into simulations and this and that might be aware, or business processes, that for a long time P-tree nets used to be used as a formal mechanism to model multiple activities, some of which could go on in parallel, some of which have to happen serially and such, trying to prove deadlock-free or liveness kind of properties of such networks. Similar things are being talked about here. And then you might want to take that formal contract in which you have proven certain properties and then come up with an executable contract. Okay? All of this is being researched on right now. Okay? IBM has a long track record in this space. I already mentioned the fact that we developed originally a prototype and then open sourced it and formed the Hyperledger Consortium in order to make other people also become part of this effort. And that's how the Hyperledger Fabric project came into existence. But since then, other projects have come about, and IBM has this blockchain as a service offering and things like that, and on and on. So this is the offering that we have now, where on top of the IBM Cloud, you have the Fabric, which is the base platform. On top of it, a much more recent project that got initiated, again with IBM doing the initial work and then open sourcing the software, is the Composer that lets you more easily develop the use case on top of the Hyperledger Fabric. This is like 4GL tools that used to make it easier to develop database application. You can also, do your own work and develop the app, but this makes it easier. It turns out the problem with dealing with physical assets and modeling them using blockchain is that if you had the real diamond at one point and along the way somebody substituted the real one with a fake one, how the heck are you going to figure this out? Because all that hashing thing that I mentioned will be useful when the online stuff gets manipulated illegally, right? Then you can recompute the hash and it will look different from the original hash. How do you deal with it when it comes to diamonds and olive oil and high-end wine and so on? So that's where IBM more recently came up with this technology that was developed in the research division, which has to do with what's called the crypto anchor verifier. So just like you have fingerprints for humans, it turns out, depending on what material you are looking at, for diamonds, for instance, the inside of the diamond has a signature which is unique for different diamonds. And so this attachment to a mobile phone's camera is a fancy microscopic lens which can be used to measure various physical attributes of that physical asset. Even things like viscosity and things like that, depending on whether it's a liquid or what and such. Saturation values, spectral values, and things like that. So even things like QR codes, which to the naked eye or when you photocopy might appear to be a continuous line, is in fact not a continuous line. This is no different from the different technologies that people have used to make, for instance, forging of currencies almost impossible, right? It's that sort of thing that can be used so that when you know something legit is leaving the factory or whatever, you create its crypto anchor, the signature, and then you stick it into the blockchain. And later on, if at some point in this chain of transitions that are happening, or transactions that are happening, if somebody does do a substitution or somebody wonders whether what they've been given is still the original thing or not, they'll compute its anchor and check against the blockchain to see are the two matching. That's the idea, okay? And it turns out this involves artificial intelligence and imaging technologies and such because it's not like an exact match. Because if you're dealing with, let's say, I don't know, mangoes and such, over time, the mango could undergo some chemical change which causes its weight to change. So if you are using weight as the crypto anchor, you better do approximate computation than exact matching and things like that, okay? This just tells you how, using a blockchain as a service offering makes life easier for you than if you were to download the open source software yourself and install it on your own machines and get going. Turns out the blockchain as a service offering has certain features that make it easier to use, also certain reliability features that are not part of the open source and such. And also, IBM found that even with the blockchain as a service offering, getting going was a bit hard. And so they came up with something called the starter plan, which very quickly lets you, out of the box, set up a 2-node network with this consensus protocol being handled by a single node. Today, it turns out in the software, for those of you who know about such things, Kafka is being used as the ordering service. This is the message passing, messaging and queuing system, open source one, similar to MQ series that was done long ago by IBM. That sort of thing will very quickly let you try out a small configuration. And then if you want, you can get sophisticated and add more nodes and things like that. So as I said at the beginning, the IBM blockchain as a service offering runs on the mainframe. Maybe some of you think, oh, mainframes are dead and what the heck is he talking about? And you are completely wrong. If you still don't know that the mainframes are being developed and enhanced, you better take note. There are still lots of money being made and all that in the mainframe space. In particular, the mainframe has certain hardware support for encryption and such to speed up things, as well as this notion of very secure way of executing computations and such, which allows these so-called secure services containers to execute not only the smart contracts themselves, but even the base platform in a way where even the operators of the system cannot tamper with the code or listen to the data that's being exchanged. So it's a high level of security, and IBM knows and is proud of the fact that this is the most secure way of doing things anywhere on Earth. And it turns out the Intel SGX has certain aspects, but it has a lot of limitations on the resources that you can put under this. So only the smart contract is typically executed in the Secure Execution Enclave, SGX, but the base platform itself cannot be executed under it because the amount of memory and disk storage that can be put under the SGX umbrella is very limited, and there are people in Berkeley at the RICE lab who are also working on these things. Ralu and such people. She's a professor there. In terms of components that are part of a blockchain network, you have organizations which have nodes, and then there are people within the organization who are individual users, and there are different privileges associated with these different entities. Exactly who can initiate what kind of transaction, similar to database systems and so on. There are different kinds of players, and we'll see soon. Remember, this is in a private blockchain environment, which means only people who are trusted will be allowed to become part of the network. And even then, only people who have a reason to be there because they are participants in this business process. How is all this accomplished? There are certificate authorities which issue certificates who know the identity and so on. Think of Uber and Airbnb kind of a scenario. Would you be really happy, as the open blockchain people would like you to believe, that you would be willing to deal with any random person out there where you don't know the identity of the person? All you know is some address or a number, and nobody knows who's behind the number. Clearly, we want accountability and such, right? So even if we as individual users of Uber don't know all the gory details of the person that's coming to pick us up, we know that the company Uber knows a great deal of stuff about that person, the real-world identity and all sorts of stuff that they've checked out and so on. Yeah, even there, of course, there are some bad people who try to get away with, in some cases, literally murder. But then, the law takes its course and fixes these problems, and soon they get booted out of the system. So similar things are done here. The point being that in a network where you know the parties, the chances of some people misbehaving are a lot less than in an open blockchain environment where anyone, anywhere, willy-nilly comes and goes and such. And it's because of that aspect that the open blockchain go through a very painful, expensive, time-wise, resources-wise process of trying to validate by using this proof of work and other consensus protocols. That makes it awfully expensive. And also in this day and age of green consciousness and so on, it's really mind-bogglingly dumb to waste so much energy and such. Yeah, some of the hardware vendors are happy, TSMC included, because they made some money building these special purpose things and so on. But as a society, it's not at all right for us to be spending so much, wasting so much energy, and also cooking up something that's like making something out of nothing kind of thing, which is this notion of a money being created with no real relevance to real-world productivity and goods and services and such things. Okay, so we'll get into some of these details. So similar to in a database system, you have players like application programmer, system admin, database administrator, and so on. In this context also, roles have been defined. So you could be a blockchain architect, you could be a blockchain developer, a blockchain network operator, which in this case of this IBM blockchain platform, it's IBM, and with the Oracle Cloud Service, it'll be Oracle or Huawei, and so on. You also have the individual blockchain user, who may be a clerk within let's say, Safeway, right? Or somebody that procures vegetables for Safeway, and so on, right? There's Safeway, there are farms which are supplying stuff to Safeway, those are organizations, right? And then you have this membership service thing, the one that issues certificates and so on. And then you have still access to traditional database systems and backend transaction processing systems. Because I might accept an order through the blockchain way of doing business, but the actual fulfillment of the order in terms of manufacturing whatever needs to be put together, or joining a bunch of stuff, configuring something, that can be done through traditional means of pre-existing software, whether it's SAP or some other manufacturing system or whatever. Once that article is ready to be shipped out, then you come back into the blockchain way of doing business and say, hey, okay, I'm done with producing this. Now let's go send it to the people who asked for that item. So what does the composer let you do? It lets you more easily define the elements of your solution, which has to do with what the assets are, diamonds, packages, and so on, what the transactions are that you can perform on the asset, which is like polishing the diamond, breaking it, and such. And then there is associated logic to implement. This is no different from the priest who asked the groom, are you willing to marry this woman? And asks the bride, are you willing to marry this man? And then declares, okay, this marriage has now taken place. That's a state transition. And the rules that are being enforced are this questions being asked of the two people. It's those sorts of things that are associated with each state transition and whatever the asset is that you are managing using the blockchain. And so the smart contract itself codifies these things that you have to get asked about and agreed upon before you are allowing that transition to happen. And all of this is done in a way where the different parties who are consulted, who give their blessing and such, will certify that they agree to it. And this is what that makes it very easy to later on prove. When somebody says, oh, I didn't actually give my approval, you flash the approval that they gave because their signature is there, their digital signature and things like that, okay? And then you have the participant registry. These are the people that I said who have the privilege to execute these different transactions and so on. And that's no different from access rights management in a traditional database system and things like that. So it lets you define this model of your particular use case nicely, and then you can develop the thing to be run on the Hyperledger Fabric platform. As you can imagine, this could be generalized so that instead of the target being just the Hyperledger Fabric, it could very well be something like R3 Corda or Hyperledger Sawtooth or some other kind of blockchain system. But today, it's restricted to only working with Hyperledger Fabric. So remember I said you might be a pre-existing set of entities that are already doing things with one another in that chaotic fashion that I showed in that initial slide. And I said, hey, in order for you to benefit from the blockchain way of doing business, where you have much more accountability and tracking and everything, you need to come up with these smart contracts and such that are collectively defined. And I said, it is a painful transition you have to undergo. There are various ways of skinning that cat. Instead of everybody that's an organization that's a participant in a particular blockchain network sitting around the table and collectively defining the smart contracts, what they are supposed to also enforce and so on, it's possible that the big wheels in the network, namely, let's say, Safeway and Walmart, they get together and decide what these things are, and then they let the minions just merely take those things and install them in their shops, the minions being the suppliers and so on, right? Or you can be more democratic and everybody actually sits around the table and does this. Or you could have, as it happened in Canada, where a bunch of banks wanted to do the know your customer kind of application. Instead of doing the work themselves, they decided to let a startup do all the work. Secure Key is that startup which implemented this know your customer application for these 4 or 5 Canadian banks to work together. So this is just telling you about these sorts of things. Turns out there are many, many use cases. I've already rattled off a few that have been working on this for more than 2 years now. Some of them more recently, some of them for about 2 years. And there is even a book that talks about how the blockchain technology has the potential to become like the next coming of the internet in terms of the widespread impact it can have on society, not just your and my kind of people, namely geeks, but for the man on the street kind of people. How once the internet got going, ordinary people benefited a lot from the fruits of the labor of all the techie people. In that sense here, many domains can be impacted. So there's lots of stuff here about what are all the different kinds of use cases in which it's been adopted. I have a few slides. There are also opportunities by industrial sector in terms of the feasibility, low to high versus impact, which is low to high, that McKinsey has come up with. I'll let you guys see all this at your leisure. In the food space, I already talked about how things happen, how when there are some major disasters, food poisoning and so on, today mass recalls are done, E. coli or whatever, right? Whereas with this blockchain way of tracking things, you can have more targeted kinds of recalls because you know exactly from which farm this particular dishes ingredients came from, and as a result, only those people who bought the stuff that was produced by that farm need to throw away whatever they have in their freezers and so on. Same sort of thing with, in the case of global trade, shipping, the world's largest shipping company, Maersk, which is a Danish company, they've been working with IBM for about 2 years now, tracking packages. It turns out there are an unbelievable number of entities that are involved when a container goes from one country to another and with its all component boxes and so on. And they have a hard time giving real-time information about where things are at any given time. And so increased speed and transparency for cross-border transaction through real-time access to container events and such. There are also organizations like the Singapore Port Authority, which wants to get into the act of deciding dynamically based on actual ships' arrival times and so on, to switch sending a particular container from the original one that they were going to ship it in to a different one because they noticed there's a delay and things like that. So instead of the shipping companies themselves getting into this, the port authority wants to maximize the use of the space in the port itself and provide better response to customers and so on. Governments are very eager to leverage this to reduce corruption and also make life easier for the citizens. So Dubai wants to become completely paperless with respect to government work by the end of 2021, although the thing says 2020. That was their original target. Abu Dhabi and Dubai are competing with one another like crazy in adopting blockchain technology. So the idea here is you walk into the office, you prove who you are with biometrics because you have a card which has your biometrics. Once you have done that, this government office in Dubai at which you are trying to get some service will know your full story, who you are, what your salary is, how many kids you have, how old you are, blah, blah, blah. You don't have to be supplying all those documents every time you wander into an office. You are eligible for this being free, that being given to you at 50% and so on. Similar stuff with IBM and FDA working together. So they want to focus on oncology data, tracking exactly who gets to see it and who actually was provided that information and so on. So maintain transparency in what data is going where and things like that. Secure weak spots in sharing process. HIPAA regulations are very important in this space, healthcare space. As I said, lots of work in the form of consortia. The latest consortium to come into existence, which was already early last year, was the Enterprise Ethereum Alliance. Long before that, the Hyperledger organization had come into existence. This picture shows you what some of the elements of the system are in any blockchain system, private blockchain specifically. The top is the blockchain data structure, which is the sequence of blocks. It turns out based on some of the things that were done with this proof of work that I mentioned, it's possible that multiple people might win simultaneously the competition that's set up to determine who gets to add a new block. And as a result, in an open blockchain, the chain might have been really a linear chain and suddenly there is a fork. It's like multiple versions of software being developed from the same base, right? Diverging versions. And this is a nuisance. This is part of the reason why that 10-minute per transaction kind of response time is there. Because now these two forked branches could keep going forward. And they try to sort of incentivize people to make the longer fork be the ultimate winner and declare that the shorter fork is the loser. And this is the reason you have to wait for a fair amount of time, and even then it's only asymptotically guaranteed, not 100% guarantee. So there's all this, if you like, non-deterministic behavior in the case of open blockchains, and we get rid of all that with private blockchains by making it completely deterministic. But in any case, exactly who gets to add a block and when and so on is determined by the so-called consensus protocol or layer, and that is the proof of work, proof of stake, proof of asset. And IBM and its partners used to use what was called practical Byzantine fault-tolerant algorithm that was developed by Barbara Liskov, the second woman to win the Turing Award at MIT, and her students. But in the latest release, 1.0, the Fabric guys decided in the interest of performance, they are not going to worry really about Byzantine behavior, and they went to this using Kafka as the way of doing this consensus layer. Even the execution of the smart contract and the language in which it's coded, there are variations across different systems. And it turns out because of the particular way in which these transactions get executed in a blockchain, all sorts of restrictions are placed on what you can do in your smart contract code. Namely, it cannot be a Turing complete kind of language, because that can result in things like tossing a coin and looking at the position of the moon and so on to be done, which if the same contract is executing on behalf of a single transaction in multiple locations could result in mismatches because it's not deterministic. So various constructs like that, RAND function and so on, are disabled when you specify a smart contract by restricting the language features that are available to you. Also, in terms of the database in which the asset states are being persistently tracked, as opposed to the blockchain data structure, there are variations. Some people use relational databases, some people use key value store and things like that. So in general, what you'll discover is that for various architectural features, different systems have made different choices, and they haven't bothered to really, in a very systematic way, justify why they did what they did and compare and contrast these different choices made by different systems. There is a start that was made in this paper that I've listed at the bottom. You'll get the full reference in that page I gave you the link of at the beginning. But this is the reason I said, one of the reasons, that there's scope for a lot of interesting work to be done by researchers and people looking for thesis topics and things like that, or even companies that want to provide certain features to give you the ability to evaluate different systems with respect to certain features and so on. So if you're trying to look for startup ideas or new projects, even in established companies, there's lots of stuff that can be done. In terms of comparison with database systems, distributed database systems with replication, turns out there is less reliance on all that tracking and such being done in a very methodical way in a traditional database system. As a result, a transaction might start in one place. Once it gets executed there, then its effects are propagated to other copies. So there's a notion of master copy and then slave copies. Because of that way of doing business, where there isn't this idea of these are different organizations and you can't do something unless multiple of these organizations that are party to the particular transaction give their blessing. The blockchain way of doing the same thing becomes a more elongated process, even in a private blockchain. And hence, performance is not the same as in a traditional distributed database with the notion of master copy and then slave copies. Because the master copy gets updated, and with less expense, you are then able to propagate it to the other guys. There are more details I can get into if you're interested as to whether you just rely on the log record from the master to replicate the changes, or from the master's log records you generate SQL statements or some high-level database constructs, and then you re-execute them in the other places. Because the second way of doing it allows you to have different database systems and with different page formats and so on. Whereas the first way of doing it, where the log itself is processed as if you are in a restart recovery mode, means the configurations and the system version and everything has to be exactly the same. It's as if this node itself crashes and comes back and uses its log record to do restart recovery and provide transactional atomicity. So that is a lengthier, very deep technical conversation. We can have it, and I've discussed it in some other presentations. So I welcome you to go look at some of my other videos also. This is the one that is again based on work done originally at National University of Singapore with their collaborators in even mainland China, where they came up with the first blockchain benchmarking framework, similar to some of the things that have gone on that many of you probably know about, which is the Transaction Processing Council, which came up with TPC benchmarks, B, C, D, and so on, which have been the bread and butter of how different vendors' products, DB2, Oracle, and such got compared, and hardware architectures also, Power machines versus Intel machines, and other RISC machines and such. So these guys have combined elements from the OLTP benchmark and the OLAP benchmark, online transaction processing and online analytic processing benchmarks, to come up with elements that exercise different components of a blockchain system, namely the application layer, the execution engine, the data model, and the consensus layer, and things like that. And they did some comparison initially, but what they did initially is not so important, but the idea behind this is what is more important. And they made the architecture also pluggable, so even other systems that they didn't evaluate could easily be compared by, developing something that is consistent with their pluggable architecture, APIs, and so on. The Hyperledger Caliper project is a much more recent activity, which is in the context of the Hyperledger Consortium, trying to do these sorts of things that the university guys had done. You can think of this as maybe, baby steps towards forming something like the Transaction Processing Council, but it's still in its very initial stages. There is a comparison of Ethereum, Fabric, and Corda. Ethereum being the still open blockchain, but follow-on to, if you like, Bitcoin that I said generalized the notion of what the assets were from just a single currency to any kind of asset. Fabric I've already talked about. Corda is a completely different kind of system that was developed by a bunch of banks that wanted to, in the banking domain, have as part of the conceptual model of the blockchain even more specific things that were relevant in the financial domain. And so this is where I said the conceptual models themselves are different between these different systems. There are certain features in Corda that are not there in Fabric, because the Fabric is a very simple, basic system, but you can add anything you want on top, but you have to program those things. But the Corda guys, since that consortium was formed by a bunch of banks, they made it extremely specific to the banking domain. I've already discussed some of this, Ethereum, and how it still has many features similar to Bitcoin, and hence performance is also a problem. It has its own currency. Unlike Bitcoin, it has something called Ether, and also they have a way of charging for time by having something called gas. But the more interesting development is the Enterprise Ethereum Alliance. The JP Morgan guys developed in-house some system that they were using initially to do blockchain, which was adding the private blockchain aspects to the public Ethereum blockchain. And then they decided to open source it. And for a while, it was believed that Quorum will be the basis for Enterprise Ethereum Alliance. But then over the last year or so, there was a lot of confusion about exactly where EEA was headed. Ultimately, it turned out they decided to not have a single system as part of EEA, but let 1,000 flowers bloom kind of thing. So Quorum happens to be one of them. And it has its own way of doing things that are not necessarily the same as how Fabric has evolved over time. And I'll come to what that is, which is, remember, in an open blockchain, anyone, anywhere can see what's going on. And they can come into it and go out of it without having to even announce the fact that they got in and they got out and so on. Which also from a scalability perspective is mind-bogglingly inefficient and makes it really, really performance-wise bad. Apart from the fact that everybody gets to see what's going on. Imagine, even in a private blockchain network, it turns out, if you have Safeway and Walmart on the same network with presumably lots of common suppliers, also some suppliers that are unique to one or the other, Walmart doesn't want Safeway to see what all goods it's buying, when and at what quantity and so on. And the other way also, right? This guy doesn't want that guy to see. So they said, hey, in a private blockchain, for instance, in Fabric, in the 0.5 and 0.6 releases, once you got admitted to the club, allowed to be part of a private blockchain network, you got to see everything that was going on there. Even that they couldn't, just let go. They said, we want more privacy than that. So the notion of what's called over there in Fabric, channel was introduced. You all know about Venn diagrams. Essentially, you have a set of items. You can now define subsets with potentially overlaps, right? And each subset is called a channel. So even though there is a single blockchain network, with respect to each channel, you have its own blockchain, its own state database, and its own smart contracts. But what's common is that the identities are all the same and so on. So I and Jeff could be part of one channel, but I could be part of another channel with somebody else. And then there could be a third channel which involves all three of us. Because there are certain transactions where the three of us are involved, but there are certain transactions that he and I do, and certain transactions that I do with somebody else. So now you have complete disjointness with respect to what happens in the context of a certain channel. Whereas these guys, in the Quorum way of doing business, they did it differently. They said there are certain things that are common across all the nodes. They call that the public state. That's visible to everybody, that gets described in all its glory in the blockchain data structure. But then there are some of these things that are private to a subset of the people, and then they, in the blockchain, don't describe the details of such subset transactions. Their state is kept in the state database, in the private state database. So you see some blue and different colored things. So only the guys who are allowed to see a particular transaction's activity have a copy of that transaction's states that were created. The problem with this is that in the Fabric way of doing business, the whole story is in the blockchain. So what is in the state database is merely the latest state of all the assets that are talked about in the blockchain. So you can easily blow away or even if it gets blown away, the state database, you can, in a laborious way, go through the whole blockchain and reconstruct the state that was the final state of each of the items that's still in existence that is reflected in the state database. Whereas with this picture, it turns out if one of the blue ones is blown away because the drive crashed or whatever, you cannot now just go into the blockchain because blockchain only has hashed version of the information. It doesn't reveal the full details. And so you really have to go to one of the other guys who still has a copy of that thing and get it. And this is, in some ways, inconsistent with how things have been done so far, where you don't rely the other guy to give you directly the current state. You rely on this data structure, the hash-based way of doing things and all that, that's part of the blockchain to know that what you are getting is the legit version and not some tampered version, because the state database itself doesn't have the exploitation of the hashing and so on. So anyway, there's a lot of detail, but so the Hyperledger, as I said, has many projects, the Fabric having been the first one, another one being the Composer that I talked about that IBM contributed, but there are others which were initiated by other companies. In particular, Hyperledger Sawtooth was initiated by Intel, and it's still the major contributor to that thing. And there are even more things like a Burrow, Hyperledger Burrow and Hyperledger Indy, which have to do with taking the Ethereum virtual machine that was developed in the context of public blockchain, taking those contracts and executing them on the Hyperledger Fabric. This is a way of leveraging the talent pool that's out there that's very knowledgeable in the so-called Solidity language in which smart contracts are implemented in Ethereum. And so there aren't as many people that are out there for the Go language in which, to begin with at least, smart contracts were to be implemented in Fabric. Now Java is also being supported. So it's all a point-in-time statement and also giving you some level of portability from Ethereum to Fabric that's currently ongoing. There are lots of details, I won't dwell on them. It turns out, as I said a few minutes ago, the major change going from the pre-1.0 release to the 1.0 release was the introduction of the notion of channel to provide you additional isolation in terms of who gets to see what, but also providing you additional scalability, because now transactions across different channels can go on in parallel, and hence you can scale better. But also, there are a few other things that were introduced. I won't dwell on them too much. But currently, there's a great deal of momentum behind the Fabric because it's not just IBM that's behind it. But as I said, Oracle has announced support for it, and there are other Chinese software houses that also have adopted it and so on. So it's in a much more mature state from a industrial strength viewpoint and things like that. So in terms of details as to how things work, when you have an application that's running on the client side, which is initiating a blockchain transaction, that is essentially an invocation of something like a stored procedure smart contract on the server side, where some input parameters are provided. It could be a state transition like you bought a ring, or you mounted a diamond on a ring that didn't have anything on it, and so on. As the smart contract executes, it makes calls to the database system, which is the one where the current set of assets are maintained, and you are attempting to read the state there and also modify the state there. It turns out in the initial stage of executing a transaction, no updates are actually performed. Only reads are performed directly in the database system. Any writes that the smart contract wants to perform gets cached. This is the so-called optimistic concurrency control way, for those of you who know about database systems and locking-based approach versus optimistic concurrency control. So this is a simulated execution of the transaction in which you are trying to determine each transaction's read set and write set. And this is where the inefficiency of the blockchain way of doing things comes, because while it's going on one node, any other node whose blessing you have to obtain in order to permit this state transition to go through would also be simulating the same transaction. So in parallel, multiple entities, the so-called endorsing peers, will be performing this simulation of the transaction. While this is going on, event notification can happen, because a single smart contract might invoke another smart contract. It's like abstract data types. Each smart contract owns certain piece of data. If one smart contract wants to look at another smart contract's data, it cannot directly access it. Instead, it has to invoke a function in the other smart contract to read or write that other smart contract's data, exactly like ADTs. And so these are the notifications that might happen. A transaction got initiated, it did this, it did that, and so on. At the end, when control goes back to the client, that designates the end of a blockchain transaction. So ideally, we want to execute a single blockchain transaction as a single database transaction, okay? But turns out, because a lot of these systems have used some flaky NoSQL database systems as the underlying state database, they don't typically have full-blown transaction support. All sorts of accommodative things had to be done on top, which have reduced concurrency and things like that. And as a result, the transaction throughput is not as good as it could be. So these are the sorts of places where database guys like me get involved and try to fix up things to improve the story and so on. That's my ongoing project. I won't talk about it right now, but so the idea of this, some nodes being designated as endorsing peers and other nodes as ordinary peers, is another change that was introduced in version 1 of the fabric. So I'll get into that in a minute. So diagrammatically, so what you see on the left is the blockchain, which is very much like a recovery log, as I mentioned before, but it has more stuff in it than a typical recovery log, because recovery log only has writes in it. Here, even the reads are being recorded. And the state database is where the latest states of the assets are being mentioned. People will tell you, oh, this blockchain is an immutable database, and once you put something there, it stays there forever, and that's the bad aspect of blockchain, and hence we want to keep some of the sensitive information off the blockchain in a regular kind of database, and only keep the hash of what's in that regular database in the blockchain. This is now like a half-ass way of, compromising on what you thought you were getting out of the blockchain by going back to the traditional database way. people don't typically address who's the one guy who's going to manage this off-chain database. Why is that one person special compared to all the other, peer-to-peer kind of thing that we all were bragging about as the good thing of the blockchain way of doing business? Also, all it lets you do is, if somebody mucks around with this in an illegitimate way, and hence the hash changes compared to what the blockchain says is the legitimate version of the document's hash, you just discover that it's been tampered with, but you don't have a way of getting to the original thing. Whereas in the blockchain way of doing it, because there are multiple copies and so on, even if one is messed up, you can go to the other one and get the original version. So some of these sorts of things are still in a hand-wavy way dealt with by people who say, oh, blockchain might not be appropriate for sticking huge documents. Hence, I'm going to keep it in a regular database, in an off-chain database, and then on the chain only keep the hash and things like that. Okay, so there are many things like that that one can talk about. And there are indexes, very simple-minded indexes that let you get into this hash chain and the blockchain data structure. This is something that you would need to do if you're interested in doing analytics on the past states of these assets, not just analytics on the latest state. But even the latest state, if you want to do analytics, if this is a Mickey Mouse database like a NoSQL, which doesn't have the full power of SQL, that's also a nuisance. This is why you might have to extract the data from this Mickey Mouse database system, as I call it, and have to stick it into a real industrial string database with more powerful APIs and so on to do analytics, which is harking back to the traditional OLTP versus OLAP kind of database system, which has lots of issues. And ideally, we would like to make this a more industrial string DBMS with all sorts of fancy features, which is a HTAP database system where you can do in-place analytics. And of course, there's no reason why this cannot also contain the historical states. Right now, it contains only the latest state, but there are bitemporal database systems and transactional SQL and so on, temporal SQL, which allow you to even do queries that involve state changes themselves. And because this is not a real database system, this is just a sequential file. And so doing anything on this is a pain in the where. There's lots of, for database people to work on. So the three-staged execution of a transaction in the blockchain, in the Hyperledger fabric specifically is, like here. So initially when the client is invoking a blockchain transaction, as I said, what I showed in that earlier slide was the execution that happens in one node. But the transaction is actually submitted to more than one endorsing peers. This is where you are trying to get their blessing and so on for the state transition. This is the simulated execution, which results in read and write sets being determined. And then they get sent back to the client, who compares what it got from multiple people. And if they are all in agreement, then it says, okay, this transaction can now be scheduled to get executed in its true form. Because no updates were done in that simulated execution. Nothing is remembered by those endorsing peers of the fact that they started the execution, did the simulation, and sent back something. It's amnesia time for them once they finish the simulation. This ordering service is a simple-minded thing in this system. Unlike in the open blockchain world, all this guy does is it receives a bunch of these transactions with all the signature and the read and write sets and so on, and puts them in some random sequential order, one transaction at a time, produces a new block, and now ships it to everybody, including the original endorsing peers as well as the non-endorsing peers. In any given transaction, only a subset of the endorsing peers might have been brought to bear on the simulation. That's all decided by the client. What do each of these guys do when they receive a new block of transactions? They step through one transaction at a time. They pull up the read set. They peep into their own databases, the state database, check to see, are the items that were originally read in the simulation still in the same state? If they are, then that means that the validation has succeeded. At that point, they just take the write set and dump it into the database. No smart contract execution, nothing at that point. It was all done only during simulation. And that's the reason these committing peers don't even have the smart contracts installed in them. They are merely tracking the state changes for the successful transaction. Presumably, those nodes will be used to do analytics and such things on them. They are also not necessarily aware of what the rules of engagement are, and that's also considered somewhat of a secretive thing and things like that. Maybe a trade secret, whatever the thing is, right? So the point is, it's only in step 3, if validation succeeds, that this transaction actually is declared to have successfully executed, and hence its results get put into the database. And that is a committing of the transaction. As you can tell, there is this lengthier process that you go through in order to realize the effects of a transaction in a persistent way. The idea is that in step 3, these nodes themselves won't be talking to one another, peers, but they'll all still arrive at the same result. If the transaction fails validation in one node, it would also fail validation in all the other nodes, is the assertion. What does failing validation mean? That means that one or more of the items that were originally read during simulation have changed meanwhile because of other transactions that could have executed in between, and hence that transaction is declared a loser transaction. None of its changes is incorporated in the database. All right? It turns out this model of executing transactions is quite different from the way the other blockchain systems do it, as well as even in the fabric. Prior to version 1, this is not the way the transactions got executed. Prior to version 1, all transactions went to everybody in the network, and they all went through the same set of steps, and that meant that it had to be deterministic. And it was expensive, and also in the open blockchain, you didn't even know who are all out there. So it was more like a propagation that happened at its own pace and so on, and each guy sent it to his neighbors and such. There was no global knowledge of who all was out there and so on. So there are more details about all this if you are interested in the geeky aspects of this in that paper that I've cited there. And also, in terms of the endorsement policy, which is how does the client decide how many people to send it to, and what do each of those guys have to agree to or not necessarily agree to, that determines whether or not you go from step 1 to step 2, is all left up to the designers of the solution. And so we give you a way of giving a specification, which could be that Jeff is an important guy, so he has to bless every transaction, but amongst the other 4 people that were consulted as the endorsing peers, it's enough if a couple of them are in agreement. That sort of policy specification is what this endorsement specification is. There's a lot more geeky details, and there are various database aspects to this that are also painful, because now the layer of the fabric that sits on the database system that's doing the simulation thing has to understand the database APIs and so on, and this will get to be really hard if the API is not this simple-minded key value store API, but it's actually a more powerful SQL kind of database API and such. So I'll just flip through the rest of the slides just so that you know what's there. I talk about the R3 Alliance and the Corda system that actually leverages relational databases, and it has the notion of on-chain and off-chain and such. They even operate behind the firewall and things like that. They have higher level concepts because, as I said, it was developed originally in the context of banking sector, with a bunch of banks getting together to form this consortium. So they have some of the financial industry kinds of elements as part of the architecture, it's as part of the conceptual model of their system itself. Cash and bond contract and cash contract and things like that. They even keep track of, over time, how different transactions caused subsequent transactions to come about, a transaction history, if you like. Dependencies between transactions. Such things don't exist in the fabric. Sawtooth relies on SGX and such. It's a way of also doing consensus that's different. It's called POET, proof of elapsed time as opposed to proof of work. They have certain features that lets them do more than one transaction in a given block that have conflicting data associated with them. It turns out in the fabric that validation succeeding or failing that I talked about has the bad aspect that if in the same block you have multiple transactions which got simulated in parallel, which happen to read and write the same piece of data, then simulation would have succeeded. But then at step 3, only the first of such transactions will succeed and the rest will get blown away, because the first guy's success means that the state would have changed for that particular piece of data, which these other guys also read the original version of. Now they'll realize, oh shucks, that's not anymore the current version. So concurrency is affected by that. Microsoft has done something. This is a repeat of that original slide that I showed, which said many architectural features had different choices being made by different systems, but there is no rationalization and all that. The project I'm doing right now is replacing the get, put, delete kind of key value store APIs that are being supported in the fabric today, and hence it makes the job of the writer of the smart contract be very painful, because this is like harking back to 40 years ago way of doing things, in terms of the richness of the model that you are having at your disposal to model the assets. You have a primary key and then a bag of bits. The interpretation of the bag of bits is left up to the application. The database system has no knowledge of the structure of this, which is even worse than ISAM and VSAM files and even IMS kind of database system, which is pre-relational, where you have not only the primary key, but many other fields that are individually named, typed, and such, which you can refer to in your manipulations and such. Lots of open problems, as I said, which can be the source for projects in terms of, or products, both research kind of things as well as technology developments, and lots of places where you can go to read up on other related stuff I've presented, and videos as well as PowerPoints, and also keep up with this topic if you are interested by following me on various social media accounts. Thank you.
Thank you very much, Mohan.
Welcome,
I think we have time for a couple of questions if someone would like to ask a burning question after the tutorial. Obviously, he'll be here during the coffee break, as well as I offered him a free lunch, so he'll be here for lunch. Are there any questions from folks in the speaker?
Sure.
So please. Please state your name and affiliation before your question.
Sarah Biabani, GridCom. A comment and then a question. So you talked about various areas of application, and one big area right now is the energy markets and transactional energy that you might want to add.
Yeah, I mean, it's actually, by the way, I should point this out. You might or might not have observed the fact that the numbers were not sequential. That's because if you go into the non-slideshow mode of this presentation, you'll see lots of slides that have been hidden, okay? So energy is definitely an area. There are people who are doing all sorts of interesting things with blockchain technology and combining it. In fact, I was in Aalborg in Denmark in April giving this presentation, and they also organized, separate from a 2-day event, where I was teaching the PhD students, an event where other people also presented. And the professor who hosted me, he is working on energy management and all this, home-generated energy and such, using blockchain technology. And there are also people who are dealing with carbon credits and such too.
Great, yeah. So the question now, so you mentioned, we are computer architects, we want to know the performance impact of all of this. So
Right.
You mentioned the comparison between different blockchain implementations, but in the context of IBM's implementation of your Hyperledger, have you done any comparisons of the blockchain methods and traditional methods, especially regarding server compute impact and the network utilization and database size and all those kind of stuff?
So that paper that I pointed to, where I said there are a lot of technical details about how transactions execute in the fabric, It's actually a 22-author paper. It was published in April at Modern Operating Systems kind of conference. That has some performance numbers, but the way they did the comparison was more between open blockchain and private blockchain. So they essentially simulated Bitcoin in Hyperledger Fabric. Okay? As far as I know, the kind of hardware thing that you might have in mind has not been done. Running the Hyperledger Fabric on, let's say, the mainframe versus on Intel or some such platform. That sort of thing has not been done. So, like I said, we are now at the stage where relational databases were 40 years ago. These are just the initial stages of production-grade private blockchain systems just being released, with all sorts of bells and whistles, which are left up to the users to set. There's lots of stuff to be done. You know, IBM used to put out these red books, which are like cookbooks on what's the right way of using the system, under what conditions, what features should be used, what are the right values to set for these various knobs and so on. That's all to be done. Okay?
So I see two more questions, one on the left, and then
Okay.
we'll do the one on the right, and then we'll take the break.
CCUM with S-Core. So thanks for the excellent talk about the IBM software platform. Since this is a hardship conference, I'm wondering on your page 31, you have one page you quickly mentioned how the layers, architecture layers, IBM supported. In hardware related, you mentioned you have HSM, the security model, and also the encrypted storage. Other than that, can you elaborate a little bit more about how you modify the hardware to
Well, right now, the
performance challenges? Thank you.
Yeah, I mean, at this point, there isn't a whole lot of stuff that's being specifically leveraged in the hardware by the private blockchain systems. On the other hand, if you look at the open blockchain ones, because they have that proof of work where they are trying to solve this math problem as fast as possible, to be the first guy to do it so that they can get a few biscuits, bitcoins. There's like reward for having won that game, which is where all this ASICs and all that TSMC and other people have developed. By the way, I was asked to speak to AMAT people, Applied Materials, as well as KLA-10 core people, because they're all dreaming that maybe they can also make more money by doing something special purpose. But I'm unfortunately not happy with this whole notion of open blockchain for various reasons, as I mentioned. So in the private blockchain space, if you're encrypting the data, or like in a regular database system, you're doing some computation that is expensive, where things like FPGAs and GPUs are being leveraged, you could do that here. But at this point, at the layer that is the blockchain platform, that itself is in a very simple way doing things. So it doesn't have the sophistication of a SQL kind of language. That was my point towards the end. And as a result, the manipulation that's being done of the data is being done in a very simple-minded way, at least from what is visible to the blockchain platform, because the APIs are so simple-minded. It doesn't have fancy aggregation, that kind of operators. And so in the IBM blockchain platform, the leveraging of the hardware is happening for doing encryption and such efficiently, and also to provide the secure execution environment where there are hardware features with that secure container and such notions that come into play. But beyond that, I'm not aware of any interesting leveraging of some very unique kind of hardware features.
So you implied also Ethereum is a transfer from POW to POS now. And your IBM actually is not planning to do anything.
Did you catch that? I didn't catch the pure something to pure something.
From POW to POS.
POW to POS.
Oh,
Proof of work.
yeah. So like I said, in our system, we used to use PBFT. I shouldn't say our system. This is actually an open source system. In Hyperledger Fabric, in 0.5 and 0.6 release, the consensus protocol being used was PBFT, which is the practical Byzantine fault-tolerant algorithm that Barbara Liskov and company developed, which still had the property that it was deterministic. Only one guy got to add a new block, okay? It wasn't the one where, like in proof of work, where multiple people could add. But even that has been given up in version 1, where it's Kafka that's being used, where all that happens is that these clients publish on a topic, where the topic is the channel, all the transactions that they simulated in that channel, and then there is one listener, which is this ordering service, which grabs all those transactions, puts them into a block, and now it publishes the block using that same channel ID as a topic. So there isn't this proof of work, proof of stake kind of thing. But the architecture is such that if you want, you can plug in a different consensus protocol. But the base platform itself now comes out only with Kafka as the ordering service. So in that sense, at least in the fabric, there isn't any proof of work or proof of state or proof of asset or whatever. So,
Thank you.
okay.
And then our last question, please.
Yeah, hi, Charlie Demergent from Semi-Accurate.
I can't quite hear you.
Sorry, Charlie Demergent.
Maybe you should push it up a bit. Yeah.
Yeah, technology. Charlie Demergent from Semi-Accurate. A friend of mine, much smarter than I, once described the value of Bitcoin as being one hash collision away from zero. Now that we have commercial implementations with fairly large assets being guarded or tracked by this, what if anything do the commercial implementations do to react to, not necessarily guard against, this that kind of eventuality?
Well, I don't know exactly how to interpret this question because, first of all, I don't believe in any of that. So I'm concentrating only on the private blockchain. So what do you mean by guarding against it? And who are these private somebody you said?
Well, in any commercial implementation is doing something to protect something of value, or at least track something of value. If there is a fundamental attack or a fundamental problem with the underlying technology, is there a way for these commercial systems?
Well, I mean, that's what one of the first points I made, right? Which is you lose the private key, you are screwed. There is no recourse to anything. What is billed as the positive thing about this whole thing is a major negative thing, which is all this anonymity, blah, 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 that these guys will rattle on. When I go to some of these conferences, I feel as if I'm in a different universe, you know. They all will mumble decentralized, blah, 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 and, you know, providing for safe way of doing things. All that is predicated upon you don't lose your thing and that the code is all, you know, error-free, this, that, and we know about all sorts of attacks and things that have happened. And even this whole complete decentralization is a lot of BS because a lot of the money that's being held is not being held by individual people in their wallets. There are now these so-called exchanges. Big share of the stuff is now in these exchanges. Why are they not like banks? If you are claiming that banks are bad and this and that, and I'm going to completely go to a decentralized world where all of us act like there's nothing central and we are all going to work with each other without even knowing the identity. Now, if these exchanges die, again, no protection. So it's for such reasons also that government bodies are all wrestling with all this. As I said, you know, CFTC and all these guys are now declaring some of these things as, hey, you can't fly under the radar. You are now going to be subject to tracking and this and that. So the only exception they've made is that, at least in the case of the SEC, they've said Bitcoin and Ethereum have a lot less of any single organization controlling them, and hence they don't want to necessarily think of that as a security. But you are still messed up if, you know, as it has happened, people have found ways to take money away from somebody and things like that because there were bugs in the code or features in the systems that allowed them to do these things. So you can't have the cake and eat it too. If you claim you don't want any of these pre-existing governmental entities to be part of the picture, and hence you do stuff, and then again, you know, we are all greedy people, I guess. Somebody or the other figures out how to mess up the system and make money. Now, if you are going to say, hey, give me back some of that governmental control or ways of finding recourse, yeah. I personally don't have too much sympathy for all of these people because they relied on stuff where they bought a bill of goods and, sorry, face the music. Thank you.
Okay, with that, I think it's my duty to, we still have 2/3 of our coffee break left. It'll be on the right side here, to invite you to come back at 45 after the hour for the second part of the tutorial. And then my last task, if you would join me in thanking Mohan for this great talk.
Thank you.